First, it's fantastic to be here, and I see among the audience old friends, Martin, Jason, and Zach. Good to see you. Now, Professor Andrew talked about looking outside the US into other countries, and what my seminar is going to be about is looking outside the world. The whole idea of the seminar is to look at other planets, what they're like, can life exist? So these three are just posters, publicity posters produced by NASA for some of the interesting exoplanets that have been discovered. Of course, these are complete, it relies on imagination. Who knows if it's like this? So what are we going to cover? Of course, we have to start with our backyard. So we will start with solar system planets. We have Mercury, and this is Venus and Neptune. Okay, we compare and contrast them to what we find on Earth and contrast them with other planets that we know outside the solar system. Here we have high resolution, beautiful images of planets. And this is one of the best images of a planet outside the solar system, this tiny blob of light that you see. At least this is a big blob of light. For most stars, we can't even see it. And when we do, so it's these four blobs. These are planets which are bigger than Jupiter, which is why by blocking their starlight, we can just about figure out that they're there. And you can see by the timestamp here, it's a time-lapse photography where you can see the planets going around this star. So when we talk about planets around other stars, the actual alien worlds, what are we going to do? We first have to figure out how planets are detected. We can't photograph them. And if we even could photograph them, we need to know they're there. So how do we determine their properties? Are they big? Are they small? Are they like the Earth, or are they like Jupiter? Then alien planetary systems, by that I mean multiple planets around their star. Do any of them look like our solar system? How different are they? What are the similarities? And then we go to the current hot topic, habitable zones. What on earth do we mean by habitable zone? And are planets in the habitable zone really habitable? The answer, disappointingly, is not usually, but again, that's something we will explore. And the last bit would be, given that a big push of NASA is trying to find signs of life elsewhere, the first thing is, how do we define life? It's really more difficult than we would think. For example, if you say life is something that grows, you see growth. Well, given enough fuel, fire would grow. Life multiplies, crystals multiply. Are they live? So how do we define life in order to be able to be sure that we find life on other planets? And a good segue is to imagine alien life. And there's superb science fiction that deals with different forms of alien life. And that's something it's extremely interesting to explore. And I can say with confidence that many people who are into this, trying to find life elsewhere, basically, grew up reading science fiction by Arthur C. Clarke or Larry Niven, talking about life elsewhere, different life forms elsewhere. We talk a bit about the building blocks of life. Are they really the same everywhere? I mean, the problem is we only know of life as it exists on Earth. A bit of a limitation, if anything. And the last really important question, of course, is how would we recognize there's life elsewhere on those small dots of light around their planets? For who could think about taking the seminar, I would say anybody interested. It's a topic which we'll keep seeing a lot about in the newspapers. We've seen this planet and that planet. Maybe we've seen life. If you're talking a bit more in practical manners, matters about your seminar units. Upper grade levels in physics and biology. Biology will require a bit more work, perhaps, at least on my part, but it's very doable. If you're looking at the lower grades, the lowest grades, I mean, if you're talking about solar system planets, then certainly. And you could, of course, not be a science teacher at all and teach a language, in which case we could talk about science fiction, comparing them with science facts when it comes to alienids and alien lives. And what often we do in our department is use astronomy as an excuse to teach physics and mathematics. So Newton's laws, yeah, we all hear of, equal and opposite reactions, but that's how we detect planets. They actually use Newton's law. Gravity matters. Gravity would determine, could we stand on a small, highly dense planet and not get squashed? Or could a planet keep hold of its atmosphere? Or if you really want to know about properties of other planets and stars, you need to know about properties of light and properties of atoms. So as an excuse to study physics. Now, whether or not it'll be useful for people who took my seminar last year, it depends. It depends on what you would like to do. So I would think it would have to be looked at a case-by-case basis. So for people who did the units on just the solar system, it probably is not going to be very useful. But the others who sort of branched out, it should be good. So thank you, and I'm looking forward to your questions when Jim asks them.
So we do have time for at least one question for each of the seminar leaders. And Sarbani, could you say something more about how your seminar will work for English language arts teachers? We understand that humanities teachers might develop a unit having to do with science fiction. You've spoken about that to some extent, but could you say something more?
Yes, so there is a lot of literature, some beautiful, some not very good, which depicts alien worlds. A lot of science fiction depicts alien life as very humanoid, and the really good ones like Ursula Le Guin, for example, science fiction is it's basically a means to explore the human psyche. I'm not talking about those. I think what would be more interesting, for example, the book The Sparrow by Mary Doria Russell, where she talks about a different form of life and a different planet, but it's plausible. And if you really want to go into the real realms of imagination, nothing beats Larry Niven and the different types of life that he envisages, or even Arthur C. Clarke. So what could be done is a few readings, which will depend on the curriculum unit of these science fiction. They're all very accessible in the sense that these are not difficult literature. They're very accessible, and then perhaps take one of those units and then compare it with what's presented there. Do we think it's plausible in terms of the science that we know today? For example, in Sparrow, what the protagonists do is take an asteroid, hollow it out to make a rocket to go to another planet. That's incidental, but is that plausible? Is it possible to do that? Perhaps, maybe, maybe not. And the two different light forms in the planet, one extremely intelligent and the other nice and docile, but they turn out to, they happen to be the prey of the predator intelligent species, but the prey is intelligent too. So it brings out all these issues. And if I think a bit more, I think it should not be difficult at all to combine the science fiction and the science. Well, I don't like the phrase science facts, but what we know today from observations of other planets. I think it can be done. If anybody is interested, I'm happy to correspond with you so that you can figure out a proposal when you put in your proposals. It could be a lot of fun, actually. It's sort of orthogonal to what I do, but I've been a fan of science fiction since childhood. So I think I would really enjoy having someone do this sort of a unit.